Alright, hello everyone and welcome back. So in this video, we are gonna rotate stuff around a different axis than x-axis or y-axis. Okay, so check this out. In this question, we have the function 2x and x square. Okay, and then we are going to rotate it around, now not around x-axis but around the line y is equal to -5. So now how are you going to set up the volume? It's actually easy, but you can get highly confused on this. If you follow the strategy that I explained you before, the strategy of drawing radius, this stuff should make sense, but we'll see. Okay, right, the first thing is finding the intersection point. So x square equal to 2x, make two functions equal to each other, so x square minus 2x equal to 0. Factor x out, so it's x times x minus 2 equal to 0, so either x is equal to 0 or 2. So 2 here is the x limit, okay, x point of the intersection. Okay, now the thing is that we are rotating around y is equal to -5. So first thing you need to understand is decide is, am I going to, should I set this integral with respect to x or y? That's the first thing that you need to decide. Again, I'm repeating, now you're not rotating around x-axis or y-axis. You're rotating around the line y is equal to -5. So you need to decide whether to set the integral up with respect to x or y. And there's only one right answer here, okay? What it should be? Should it be with respect to x or y? What do you think? So here's the hint. So look at the axis that you're rotating. It's parallel to x-axis. So it's like equivalent to rotating the region around x-axis, okay, because they are parallel. The line that you have rotating about is horizontal, y is equal to -5. So you're setting the integral up with respect to x, okay, so it's still pi. X values are going from 0 to 2 and you're setting the integral with respect to x. That's good. Next, you figure that out. Okay, so that's the first thing you need to figure out. It's super easy thing to figure out. Okay, just see whether the axis that you're rotating around, whether it's horizontal or vertical. If it is horizontal, similar to x, so set it up with x. If it is vertical, then it's similar to rotating around y-axis, so set it up with respect to y. The radius is the second key thing. Now, what did I ask you to do in the previous problems? Draw a line from the axis that you're rotating to the function. Okay, to functions, both functions. So now the rotating axis is y is equal to -5. So from there, I'm gonna draw two lines to join the functions. Now, which one is longer? The one on the top is longer. What's its radius? Now that's what you need to decide. Okay, so this is a geometric problem. What's the radius? So from -5 to 0, the length is 5. Okay, don't get confused by -5 or don't get thrown off by negative in front of 5. It has nothing to do with it. Okay, we are looking at the length. How long is the radius? So from -5 to 0, it's 5 units long, and from 0 to until you meet the function, this is 2x long, right? So what's the real radius? It's 2x plus 5. That's the radius. That's the longest radius. That's what we are squaring. So it's 2x plus 5 square. If you just rotate this around the x-axis, it would be 2x square. But now you're rotating it around y is equal to -5. But don't let that -5 fool you. Okay, that negative fool you. No, you're looking at the length of the radius. Okay, so it's not 2x minus 5. Think it as a geometric problem. You're merely finding the length of a line. Okay, so the bottom part, it's 5 units long. That's what it is. Okay, right. So now what's the length of this line? Well, the bottom part is 5, the top part is x square, right? From x-axis to the curve, it's x square. So you add both them up. So minus x square plus 5 square. That's the second radius. The larger radius is 2x plus 5. The smaller radius is x square plus 5. Okay, so let me erase this stuff and show it to you. The larger radius, let's draw it from the red color. That's the larger radius. The shorter radius is this. Okay, right next to each other, right? So length for both of them, you have to add 5. Okay, Again, I'm saying don't let that negative fool you. Okay, this is the integral that will give you the volume of this object if you rotate it around y is equal to -5 line. Okay, right, so I'm gonna stop there for this example. Okay, that's how you set up the integral. I'm not gonna solve the integral. Now I'm gonna change the question a bit. Okay, now let me draw this graph again. So it's the line here, x squared, this is 2x, and here it's 2, that's the intersection point. Now how about if we rotate this around y is equal to 7, not y is equal to -5, y is equal to 7. Now students, what you would do is, oh okay, so then it should be 2x minus 7 here. You know, that's how you solve problems, right? You tend to solve problems, right? You change the stuff. Oh okay, now in this problem I had -5, so I added 5. Now I have 7, so I think I'm gonna subtract 7. That's how you are likely to think. No, don't get into that trap. My idea is to draw those radius and think it as a geometrical problem and literally find the length of the line by arguing, by making a logic. Okay, don't just follow a formula. That's super important. Okay, right, memorize and change stuff. Right, so here we are still setting the integral up with respect to x. Why? Because the rotating line, that's still horizontal. Okay, we're rotating around a horizontal line. Okay, so it's going from 0 to 2 pi dx. Now draw two radius, okay, right next to each other, and see which one is longer. Which one is the longer one? This is the longer one, right? So the longer one is related to x square. Now, but what is its radius? That's the important question. Now think about this. Okay, so the total length is 7. Think about this. Total length is 7, and from the x-axis until you meet the curve, the length is x square. So what's the remaining length? What's the length of this red color part? The radius, it's 7 minus x square. Okay, so the first radius is 7 minus x square, and you square that. Now that's why I said most students would write it as x square minus 7 or 2x minus 7. No, it's 7 minus x square. This is important. Okay, so think it as a geometric problem. The total length was 7, from bottom to top it was x square, so you subtract both to get the remaining radius. Same thing here, the total length is 7, so the total length is 7, so from bottom to until you meet 2x, the length is 2x, so the remaining one is 7 minus 2x. That's the height here. Okay, and the height here of this radius is 7 minus x square. For the second radius, it's 7 minus 2x. That's the radius, and you square it, and there you go. That's the formula that will give you the volume integral, that will give you the volume of the object that you get by rotating this region around the line y is equal to 7. Okay, so you set it up with respect to x because it's a horizontal line. Okay, so several things for you to keep in track of. Okay, and the important things are, think whether the line that you're rotating around, whether it's horizontal or vertical. Then based on that, decide whether you're going to set up the integral with respect to x or y, and then literally draw two radius right next to each other really closely until you meet the functions from the axis that you're rotating, and then think finding the radius as a geometrical problem, argue, make a logic, and then get the radius. Okay, right. Now in the next video I'm going to rotate stuff around a vertical line. Okay, I'll catch you in the next video.